All right, today is Tuesday. Tuesday. Tomorrow's Wednesday. This is what we went over today. We started off with a little review to see if everyone remembered these words: reflection, rotation, translation, and dilation. Okay, I'll let you think for a minute. Which one of these are the same? Which one is different? If you want to pause it and write down what you think and then check it in just a minute. All right, what we came up with is D was different. Dilation changes the shape, doesn't change the shape, but it changes the size. But when we rotate, well, I was trying to find something. If I rotate this 90 degrees, 180, 360, okay, it changes position, but it doesn't change the shape or size. If I reflect it, say I reflect it over the y-axis here, and I reflect it here, all I'm doing is moving it. I'm doing a mirror image. I'm flipping it. It doesn't change the size or shape. If I translate, meaning I move it up and over, up, down, over, it stays the same. So all of these they're all transformations. All four are transformations. Okay, but these three keep the shape and size. So if I rotate it, it's going to be congruent to when I started. If I reflect it, it's going to be congruent. There's going to be equal from when I start to when I finish, whatever one of these moves. But when I dilate, it's going to change. It's going to be the same shape, but it's going to get bigger or smaller. All right, we're going to use this concept of congruence. When we reflect something, rotate something, or translate something, it's equal. Okay, we're going to use that as we talk about our next topic, measurement topic, analyzing parallel lines cut by transversal. But first, let's look at this piece of pottery. This is a piece of Native American pottery used in a wedding. It's a vase. I see all the angles it has lots of different angles. Well, on this coordinate grid, they have given us two angles, and they want us to see what can we do to this angle. We'll call it X. We'll call this one Y because those are the vertexes. If I cut this shape, just a little bit. If I cut this shape, what could I do? What transformation could I perform to prove that it's exactly that size? Okay, so we talked about in class, one way is we could rotate. I could rotate about the origin. Okay, 90 degrees would get it there. When I come over here, this would be 180, and we've got the same shape. So this proves, because we know a reflection does not change size or shape, not reflection, but a rotation, that they're congruent. Another thing I could do is reflect. Okay, if X axis is my line of symmetry, what I'm reflecting over, I reflect here, then I can reflect here, and it's exact. And nothing changed, except for the location. I could also translate, but if I translate, it's going to require two movements, two transformations. So I can translate up, translate over, and then I have to reflect. Then I've got the same one. Well, somehow I did that wrong. Let's see, up, over, maybe we have to do something else. But anyway, we won't worry about it. So we're going to use that idea as we look at parallel lines and transversals. All right, our parallel lines, as you know, are the ones that are going to run exactly the same. They look identical. What makes them parallel is that they're the exact same distance from each other. They're never going to form together. They're never going to meet. They're always going to stay the same distance. If I measured from here to here, it'd be the same as here to here, here to here. All right? The transversal is just any line that cuts through it. Okay, my transversal could have been here, could have been this way, could have been straight up and down. My transversal could be anywhere, okay? Doesn't matter where the transversal is, but the property that we learn is no matter what, if you have two parallel lines and you cut them with another line, a transversal that's going diagonal or up and down, it's going to create multiple angles. And some of those are going to be congruent. All right, so you can see that there are actually 8 angles. Before we had the transversal, all we had was 2 parallel lines. There are no angles. You don't have an angle unless you have an intersection. So when we make the transversal, we end up with 1, 2, 3, 4, 5, 6, 7, 8 different angles. And what we did is we took our clear paper and we did some tracing. First thing we did is we traced the bottom line, okay? And if we translate this up, if we move it up, it's going to fall exactly on that parallel line because they're exactly the same distance from each other. Okay, one is not up a little bit or down a little bit. They're exactly the same. Okay, if I also just copy that part of the angle, I have 1, 2, 3, 4 angles here. If I translate up and translate over, I have 1, 2, 3, 4. They're exactly the same because my lines are exactly the same. All right, then what we did is we traced angle 7. All right, and we did some transformations to see, I'm going to see what other angles on this sheet are exactly the same as 7. All right, if I move it to 5, well, that doesn't match. 8 doesn't match. Oh, but look, 6 matches. And if I move up here, 2 matches. And I reflect it back, 3 matches. All right, so that means 3 is equal to 2 is equal to 6 is equal to 7. All 5 or 4 of those are equal. And we know that because they are vertical angles. They're across from each other. All right, the same is going to be true if we trace angle 5. Okay, if I move it here, that doesn't work. That doesn't work, but look, this vertical angle is going to be the same. If I translate it up here, that's the same. If I reflect it, that's the same. So angle 1 equals 4 equals 6, no, 8, sorry. 8 equals 5. So all the vertical angles, are congruent. They're all equal. All right, so if that's the case, 5 and 8, 1 and 4. So if 1 is 120, we know that 4 is 120. Let's use the darker pen. 120, 120. Excuse me. We know that 5 and 6 are 120. And because we know that through this line, if I make an arc, it cuts through 2 angles. That means that angle 1 plus angle 2 equals 180. Okay, angle 1 is 120 plus something equals 180. Well, if I take 180 and subtract 120, I get 50. Wait. 20. Oh, I said that. Okay, 60. So this would be 60. So this would be 120. This would be 60. This would be 60. This would be 60. And this would be 60. So when we have a transversal, no matter if they're like this, these angles are going to be the same. So let's label those X's. And then our O's are going to be the same. Okay, so we have 4 angles that are going to be one measure, 4 that are going to be the other. Isn't that pretty cool? All right, so that's kind of the basics. And then what we're going to learn is these angles have different names. We know supplementary and we know vertical. What we're going to learn is that these two have a name right here. Okay, this one and this one has a name. And there's some others, and we're going to be learning those. So thanks for watching today. I hope you're back at school tomorrow. If not, check your updates.